Here's a quick lesson, I hope, on factor by grouping. Factor by grouping is a little bit weird, but if you think about it, it's really just removing common factors. What I want you to notice here is this. I have four terms. 1, 2, 3, 4. And you can tell because they're separated by operation signs. It doesn't matter if it's plus or minus, addition or subtraction, I should say, at this point in time. But I do want you to notice that. What I also want you to notice is that I first of all made a mistake, and that's supposed to be a y. But the other thing I want you to notice is they don't have any common factors. But I do take a look and I say, all right, well, I see that this is a cube and this is a square. So what if I factor out a y squared here? What would I be left with? I'd be left with y plus 4. And if I factor it out, I recognize that these two have a 3 in common. So if I factor out a 3, I'd be left with y plus 4. Now, here's the thing. I'm going to do some work over here simultaneously. If I had y squared a plus 3a, and I asked you to factor this, what would you do? Chances are you would notice that they both have an a in common. You'd take out an a, and you'd be left with y squared plus 3. Well, that's exactly what I'm going to do. But instead of taking out an a here, I want you to notice that I still have two groups, but they both have a y plus 4 in common. So I'm going to take out my y plus 4, which is my a. And what do I have left? Y squared plus 3. And that's it. I just factored by grouping. If you don't quite get it yet, I'm going to do another example. And like I said, I always encourage people to pause and try to figure this out while we're doing it. So I'm going to do mn minus 3n plus 2m minus 6. Now, you might not know exactly what to factor at first, but take a look. These two have n in common. So I'm going to say, all right, I'm going to factor out an n. These two have 2 in common, so I'm going to factor out 2. So let's see what happens when I do that. I get m minus 3, still in addition signs. I get plus 2, and I get m minus 3. Oh, well, that's great, because this and this are common. So now I can remove those. That's my common factor. And I'm left with these two, which is n plus 2. And that's it. I'll do two more. Let's say x cubed minus x squared minus 5x plus 5. Well, if you remember from my first example, I took a look at those two and I said, well, let's remove an x squared and see what we get. We get x minus 1. Well, the problem is, I recognize that this have both 5 in common, but if I just remove a 5, I'm left with a negative x plus 1. And that doesn't seem to do much good. So that's no good. So I'm not going to do that. What I can do is I can recognize the fact that I could remove a negative 5 from both. And when I do that, this will become positive, but this will become a negative 1. And look at what I have left. X squared minus 5 times x minus 1. There is one last question I would like to do, and it's this one. It's 30xm plus 15xn minus 20ym minus 10yn. And the very first thing I want you to notice is this. This is 30, 15, 20, and 10. I can actually factor out a 5. And when I do that, I get this. Six xm plus 3xn minus 4ym minus 2yn. I'm hoping you're starting to recognize this. You have to bring down that 5. I'm going to factor out a 3x, and then I'm going to be left with, make this into a bracket, 2m plus n, and because I need the n to be positive, I'm going to factor out a negative 2, y, I'm going to be left with 2m plus n, which means my final answer is going to be 5 times 3x minus 2y times 2m plus n. If you struggled with this one, that's perfectly fine. Go back over your notes and then give it another go and try to follow along the steps. This becomes this becomes this, and then eventually you get to that. Wow, I hope you enjoyed that. I hope it was good. This is video 3, 6.1.